So we'll go over the most missed questions from Unit 2, multiple choice questions, Part A. This is just going in the question order, not the most missed order. All right, so we'll start with number 8. So this is the graph of f prime. That's kind of key right there, okay, which is the derivative, obviously. All right, the points 2, 7, and 4, 18.8 are on the graph. Which of the following is an equation for the line tangent to the graph of f at x equals 2? So since this is the graph of f prime, all right, the line tangent to the graph at x equals 2, this guy right here represents our slope at x equals 2. Okay, so our slope here at x equals 2 is 4. So right from the get-go, we can cross out A and D as our options, okay? Now it wants to know the line tangent to the graph at x equals 2, so we're going to focus on the point 2, 7, okay? So now we just plug that into our slope-intercept form. So we have y minus 7 equals our slope is 4 times the quantity x minus 2, and when we work through this, right, we get y equals 4x minus 8, but we can't forget to add that 7 to the other side, and that's where we get B as our final answer. The next question, and this was the most missed, was number 9, okay, where we're given the graph of a trig function shown from the interval a to b. At which of the following points on the graph of f could the instantaneous rate of change of f equal the average rate of change? So remember, instantaneous rate is the slope of the line tangent to the curve. So that's just f prime, right? So we want to know when f prime equals, right, the average rate. So f of b minus f of a over b minus a. So this aspect here is going to be the line that connects these two. And so what we're looking for is we're looking for our tangent line to be parallel to that red line. Okay, we want to know when the instantaneous rate is equal to the average rate of change. Okay, so we can just compare them. So if we were to, kind of draw a tangent line at A, we would say that the blue and the red are certainly not parallel. If we were to draw a tangent line at B, we could say, oh, those look pretty parallel, right? The green and the red. If we were to draw a tangent line at C, we see those intersect, so that's not going to be possible. And a tangent line at D, those are also going to intersect. So our best bet is B, okay? The next most missed is number 10. 12 of us got this wrong, okay? So which of the following statements, if true, can be used to conclude that f of 3 exists? So the first option, the limit of f of x as x approaches 3 exists. Well, this doesn't necessarily need to be true. There could be a hole here. But the limit could still exist. So that doesn't prove f of 3 exists. Okay? All right. F is continuous at x equals 3. Well, if continuous, all right, continuous implies that it exists. Okay, so that one works, all right? F is differentiable at x equals 3. Well, remember, differentiable implies continuous, and if it's continuous, that implies that it exists. So that one works, okay? So the best option is going to be C. All right, so number 11 also had 12 people get this wrong. So we're given that piecewise function, all right? Which of the following statements is true? Okay, so remember, in order to prove continuous, we need to show that the left-hand limit equals the right-hand limit, which equals f of that value. So in this case, the left-hand limit of f of x does in fact equal the right-hand limit of f of x, which equals f of 2, which in fact is 10 for both of those cases. So therefore, we can conclude that we are continuous. Okay, so since we can conclude continuous, we know it can't be A, okay, and we know it can't be C. All right, so now we need to determine if it's differentiable. So what does it mean to be differentiable? Okay, so that's our next step. Is it differentiable? All right, well, in order to be differentiable, the left-hand derivative has to equal the right-hand derivative. Okay, well, the left-hand derivative, f prime of x, is equal to 4. The right-hand derivative, f prime of x, equals 3. We get those from up above here, left-hand derivative, and then the right-hand derivative. Okay, so these guys certainly are not equal to each other. Okay, so therefore we know it is not differentiable. Okay, so therefore it can't be D, and our best choice is going to be B. So 9 people got number 12 wrong, so let's look into this one. The graph of the function f is given, has a vertical tangent at x equals 3. All right, so vertical tangent here. Horizontal tangents at x equals 2 and x equals 4. So we need to determine which statement is false. Okay, so if we look at A, f is not differentiable at x equals 3. Well, that's true because we have a vertical tangent line at x equals 3. All right. So that one's true. So it can't be A because it's true. F is not differentiable at x equals -2. Well, at x equals -2, we have a hole, so that's true. And at x equals 0, it's not continuous there, so that's also true. So both of those work, so it can't be B. Part C, f is not differentiable at x equals -1. Again, that's true. It's not differentiable there. And at x equals 1, for the same reason, we come to that cusp type point. So that's also true, okay, those sharp corners. So it can't be C. So by default, it's D, but let's just talk about why. F is not differentiable at x equals 2 and x equals 4 because the graph have horizontal tangents at those 2 points. That is false because we know that it is going to be differentiable at points at which tangent lines are horizontal. That's okay. Okay, so it is differentiable at those points. So our best option here is D. That guy is the false one. Finally, number 14, 7 of us got this one wrong, so let's just quickly look at that. If we're given f of x is 1 over x to the 6th, you know, another way we could quickly look and rewrite this is f of x equals x to the -6. That way we don't have to worry about that quotient rule. So now when we're looking at f prime of x, we simply bring down the 6 and we subtract 1 from the powers, all right, which is now going to be the same as -6 over x to the 7th, D.